Welcome back to my channel. Shall we begin? The first thing you need to do is to use the discriminant, which allows us to determine the number of real solutions. The value of b in this case is minus 6 squared minus 4 times 1 times 3, which is 36 minus 12 equals 24. 24 is a positive number, which means that there are two real solutions. This implies that the graph looks something like this, where the curve intersects the x-axis twice. To find the roots, let's use the quadratic formula. The discriminant is what's inside the square roots here, so we already know that inside of the square root we have 24. So now we know that the first root here is 3 minus root 6. And the second root is 3 plus root 6. Now we need to estimate the value of root 6. Because root 6 is between root 4 and root 9, which are 2 and 3 respectively, root 6 must be 2 point something. What is 3 minus 2 point something? 0 point something. And what is 3 plus 2 point something? 5 point something. So between the two roots, there are 1, 2, 3, 4, and 5 positive integers. So the answer is 5. In case you don't remember the table, I will draw the sine and cosine table for you. And as for tangent, because tangent is sine over cosine, and we need a value of sine 45 degrees, both sine and cosine have exactly the same value, and let's circle the values that we want. A half plus minus a half plus 1, and these two terms cancel out, so we are left with 1. 128 is 2 to the power of 7. And because the exponents must be equal, we can rewrite this equation as 3x minus 2 equals 7. And the rest should be straightforward. So the answer is 3. Find y dash through differentiation. When y dash equals 0, the value of x tells us the vertex. And let's substitute x equals 1 into the original equation. The vertex is 1, 2. 2 must be the minimum. And because 1 is closer to 0 than to 3, the graph must look like this. So we can get the maximum value by substituting x equals 3 into the original equation. 6 is the maximum value. And here's another way to solve the same question. You can find the vertex by using the following formula. X equals minus b over 2a. So the x-coordinate of the vertex is minus 2 over 2 times 1, which is 1. So this is a shortcut, and the rest of the steps are identical. And because we know the lengths of two sides of a triangle and the angle between the two sides, we can use the cosine rule to determine the length of BC. So let's plug in the values. And what is cosine of 30 degrees? So the length of BC is root 3. And now we can use the sine rule to find the angle C. Sine 30 degrees is a half times 2 root 3 over root 3. So sine C equals 1. And what is the value of angle C? When does sine equal 1? At 90 degrees. So angle C is 90 degrees. So 108 is 2 squared times 3 cubed. Can be divided by, for example, 2 or 2 times 2 or 2 times 3 or 3 times 3 and so on. So we can rephrase the question as how many combinations are there? And we shouldn't forget that we can also divide it by 1 times 1 or 1 times 2 or 1 times 3 and so on. So I recommend that you draw a table like this. So you can divide the number by any of the combinations. Since this table has 3 rows and 4 columns, there should be 3 times 4, 12 divisors. And this is the answer. So let's do some division. X times x is x squared, so we can eliminate x squared. X times plus 1 is plus x. X squared minus x squared is nothing. Minus 2x minus x is minus 3x. And we add the remainder here. So in order to eliminate minus 3x, we need to have minus 3 here. Minus 3 times x is minus 3x. And minus 3 times plus 1 is minus 3. These two cancel out. A minus minus 3, which is a plus 3. And because the question states that this expression is divisible by this, that means that the remainder must be equal to 0. So the value of A must be minus 3. So let's plug in 2 into x, which is 12 minus 4 plus 1, 9. And let's find f dash of x by differentiating f of x. 6x minus 2. So let's plug in 1. 6 times 1 minus 2 is 4. And finally, it's time to do some integration. We can simplify the expression. And let's plug in the values. And if you plug in 0, this whole expression becomes 0. 8 minus 4 plus 2, which is equal to 6. So let's find the difference. Plus 1 plus 2 plus 5. So it looks like the difference increases by 1 each time. Plus 3 and plus 4. The fourth term must be the third term plus 3, which is 4 plus 3. So the answer is 7. When two straight lines are vertical or perpendicular to each other, then the product of the slopes of the two lines must equal minus 1. So let's rewrite each equation to find the slope. Now that the two equations are in this form, the coefficient of x is the slope. So this is the coefficient of the first line, and this is the slope of the second line. The product of these two is -1. Let's multiply both sides by a minus 3. So a must be -3. Let's call this expression f of a. To find the minimum, we need to find the value of a when f dash of a equals 0. And f of a is a plus 9 times a to the power of -1. F dash of a is 1 plus -1 times 9 times a to the power of -2, which is 1 minus 9 over a squared. When f dash of a equals 0, so a must be 3, and because a is greater than 0, we can ignore -3, and if you plug in a equals 3 into the original function, we get 6. So the minimum value of a is 6. You need to know the general form of a circle. So in order to convert this expression into the general form, you need to use the trick called completing the square. So in order to complete the square, you need the coefficient of x. You need to add the coefficient of x over 2 and then square it. But remember to subtract the same thing, 6 over 2 squared, and subtract it. X minus 2 squared plus y plus 3 squared plus 8 minus 2 squared is 4, 3 squared is 9, positive 5. So now we know a is 2 and b is -3. So the coordinates of the center P are 2 and -3. And now let's find the radius. R squared equals 5, which means that r is plus or minus √5, but the radius is a length, so r must be positive. So r is positive √5. So we have our circle here, and Q is a point of tangency to the circle, and we need to find the equation of this straight line, and let's call it L. And to find the equation of a straight line, you need the slope, and you should know that PQ is perpendicular to line L. So if we can find the slope of PQ, then we can derive the slope of L. To go from P to Q, we go -2 and +1. So the slope of PQ is -2. The product of the slopes of the two lines is equal to -1. What is the slope of L? So now we know that the slope of L is 1/2. -5 equals 1/2 times 3, the y-intercept, let's call it b. The y-intercept seems to be -13 over 2. We multiply both sides by 2. 2x equals x minus 13. So x minus 2y minus 13 equals 0. So the numbers we want are 2 and 13. Coordinates are 1, -6. So 1 minus 6, so around here somewhere. but I have a feeling that R could be a point on line L. So let's plug in the values of x and 1 into the equation of line L and see if the left-hand side becomes 0. 1 minus 2 times minus 6 minus 13, and we can already see that this is going to be 0. So my suspicion was correct. R is indeed a point on line L. And because PQ is the radius, the length of PQ is root 5, and I have a suspicion again that the length of QR might be root 5 as well. To go from R to Q, we go 2 steps to the right and 1 step upward. QR is root 1 squared 2 squared, which is 5. So once again, I was correct. QR is root 5, which means that the triangle PQR is a right isosceles triangle, and the scalar product of these two vectors, vector QP and vector QR, is actually equal to QP times QR times cosine Q. And we know that both QP and QR are root 5. And what is cosine of 90 degrees? It's 0. Anything multiplied by 0 becomes 0, so the scalar product is 0. So let's find the component of vector QP. We need the x-coordinate of point Q, 3, minus the x-coordinate of point P, comma, the y-coordinate of point Q minus the y-coordinate of point P, which is 1, minus 2. So this is vector QP. And what is vector QR? The x-coordinate of R, comma, the y-coordinate of Q minus the y-coordinate of R, which is 2, plus 1. QR. So the dot product of these two vectors is the product of the x components, 1 times 2, plus the product of the y components, minus 2 times 1, 2 minus 2, which is 0. So we get the same answer. PRQ is the angle here, and because this is a right isosceles triangle, PRQ is 45 degrees. So tangent 45 degrees is 1. That was easy. And let's move on to section 3. The equation that represents graph A is, it is a parabola and the vertex is 1, minus 3, and the graph is facing up. So looking at the options that we've got, we only need to consider 1, 3, or 6. I believe the easiest method is to substitute these values into these equations. So let's do it. So number 1 is incorrect. 3. So this is the answer. Number 2, the equation that represents a graph when graph A is moved symmetrically about the origin is, so basically we have to rotate the graph 180 degrees about the origin. So the graph should look like this. And now the vertex is going to be minus 1 plus 3, and it's going to face downwards. Out of these options, we need to consider number 2, number 4, and number 5. And shall we try the brute force method again? This is clearly wrong. Once again, this is wrong. So number 5 must be the answer. The equation that represents graph B is, So graph B is clearly an exponential graph. So we only need to consider 8, 9, 11, and 12. So let's substitute these values into the equations. 2 does not equal 4. So you basically flip it upside down. So 2 equals 2, correct. So number 9 is the equation of graph B. The equation that represents a graph when graph B is shifted by -1 on the x-axis. This doesn't change the fact that we have an exponential graph. -1 on the x-axis means that the entire graph shifts 1 unit this way. So we now have a point here, -2 and 2. So let's substitute this new point into these 3 equations. Incorrect. Incorrect. So this is the answer. And the last question, number 5, the equation that represents a graph when graph B is moved symmetrically about a straight line, y equals x, is, so y equals x is a line that looks like this. And if you flip an exponential graph about this line, you get a logarithmic graph. So we only need to consider 7 and 10. For this question, we don't even need to do any substitutions because we know that when you convert an exponential equation into a logarithmic function, then the base here corresponds to this number here. So the answer is number 7. And that was it. The final section was probably the easiest one because all you had to do was basically substitute values into equations. If you have any questions, please let me know and see you next time.